Assalamualaikum. My name is ZAIM AIZAT bin ZAINUDIN from 4 BMMU4774. My metric number is B0918101008. Today I'm going to present about my research, which is the strength analysis of 3/4 jointer for joining half-inch pipe in the greenhouse. My supervisor name is TS Muhammad RUZI bin Harun. For the introduction, greenhouse is one of the most effective agriculture method for growing plants that requiring regulated climatic controls. There are many types of greenhouse, and one of them is galvanized steel frame greenhouse. In assembly process of the galvanized steel frame greenhouse, the 3/4 jointer strength is always in doubt when joining with half-inch pipe. This research purpose is to determine the actual strength of the jointer and pipe after the installation of a galvanized steel frame greenhouse. The methodology used in this research is by design and conducting static analysis using SolidWorks 2021 software. For the problem statement and objective, for greenhouse installation, multiple jointer is used in greenhouse construction to ensure that the entire structure is solid and safe. When the pipe and jointer are joined together, the strength of the pipe and jointer will be critical to the greenhouse durability. Constructors often have great concern about the installation of the jointer and pipe. Due to the extreme load that the structure will carry after the installation, the strength of the jointer and the pipe is always in doubt. It is due to strong forces such as rain, heavy wind, and environmental impact. It may be too much for the connection to withstand. In the long run, this will affect the connection and resulting the greenhouse to collapse. The research objective is to study the actual strength of the 3/4 inch galvanized steel jointer for joining the half-inch pipe in a greenhouse assembly. Specifically, it is to design the 3/4 jointer and half-inch pipe connection using SolidWorks software. Also, it is to study and analyze the strength analysis of the 3/4 inch galvanized steel jointer and half-inch galvanized steel pipe connection on the greenhouse strength by conducting static analysis using SolidWorks software. For the scope of this research are as follows. The strength analysis of the material is based on the galvanized steel material for jointer and pipe. The connection of the galvanized steel pipe and jointer is built and analyzed using SolidWorks software. Conducting the static analysis with 4000 Newton of load using finite element analysis on the 3/4 inch jointer and the half-inch pipe connection using SolidWorks software. Literature review. The advantage of GI steel. Galvanized steel pipe has a zinc coating that makes it more corrosion resistant and stronger than steel and iron tubing. Galvanized pipe has anti-rust properties and is widely used in both outdoor and indoor application. Galvanized greenhouse pipe is made of low-cost carbon steel coated with zinc. Galvanized steel pipe can last up until 15 years, require less maintenance, are easy to inspect, and are easy to construct. The extra zinc coating on galvanized pipe ensure a thick, consistent look. Their grey color can last for a long time. Galvanized steel tube has many advantages such as high strength, excellent corrosion resistance, low consumption, ease of installation, and low cost. Galvanized steel frame are unbeatable in terms of wind and load resistance. For example, the galvanized steel can withstand 400 kilos of heavy load per square meter, while aluminium can only withstand 70 kilos. It also can withstand the wind up to 100 km per hour. This is the methodology for PSM1 and PSM2. For the PSM1, it is shown in the figure 3.1, and for the PSM2, it is shown in the figure 3.2. For the material selection, galvanized steel pipe and jointer were chosen for this study. Galvanized steel pipe is frequently the least expensive option available. GI is the most frequently used material in greenhouse construction. For the joining procedure, half-inch galvanized pipe must be assembled and joined with a 3/4 galvanized jointer. For dissemination, 2 times 1.5 meter length of pipe is used to join with 150 mm length of jointer. For the load applied, 4000 Newton is selected because it is the maximum load capacity of the galvanized steel can occupy. Below you can see that there is a table of dimension for jointed and the pipe, the mechanical properties and the chemical composition for the galvanized steel. For the chapter 4, result and discussion, this chapter discusses the design process, result of finite element analysis for jointed and the pipe connection from SolidWorks simulation, and the discussion based on the result. The data were then analyzed and the result of each simulation will be presented. The static analysis. For the static analysis, SolidWorks simulation perform FEA on parts and assemblies to determine the load response. It consists of stress, deformation, strain, and factor of safety for the specimen. Static simulation in SolidWorks can simulate force, pressure, gravity, centrifugal, and temperature load, as well as load from other simulation studies. Load then will be delivered slowly without impact and remain constant over time, and stress versus strain will be linear up to the yield stress. Static loading occurs when static analysis in SolidWorks does not change over time and the load remains constant. When a body is statically loaded, each molecule stress, strain, and deformation are calculated. The results are called static analysis or static simulation. Below are the examples of static analysis that were conducted using the SolidWorks software. This is the design and static analysis process for the 3/4 inch jointer for joining with half-inch pipe in the SolidWorks. Simulation results for the galvanized steel of 3/4-inch jointer and half-inch pipe connection when 4,000 Newton of load is applied. Based on the simulation results that have been carried out, the overall mass of the pipe and jointer connection that has been designed using AIZAT galvanized steel material is 5.67 kg. Maximum bending occurs in the center of the pipe and jointer connection with a displacement value of 23.563 mm. The bending that occurs is in acceptable margin, while the minimum and maximum value of von mistress from the simulation result is 103.245 Newton per meter square and 5,019.93 Newton per meter square respectively, whereas the value is below the value of the yield strength material used, which is 6,078.173 Newton per meter square. For the strain occurred in the simulation, the minimum strain is 0.0377 and the maximum strain for the connection is 0.9461. Based on the strength analysis result, neither of the structure connection will undergo structural failure, and the design is safe if the load of 4,000 Newton is applied, because the minimum values for the factor of safety, which is the weak area of the structure, are approximately 1.2 for the galvanized steel pipe and jointer connection. That means it is greater than 1. It can be considered as safe for the construction. For the conclusion, finite element analysis (FEA) was used in this study to conduct a static strength analysis and design of the 3/4-inch jointer for joining the half-inch pipe in a greenhouse when 4,000 Newton of load is applied. Three-dimensional models of the jointer and pipe joining were created using the SolidWorks software. It was necessary to conduct a strength analysis of the jointer and the pipe that will be used with the galvanized steel material under the influence of strength and load using SolidWorks simulation in order to determine the stiffness, resistance, and reliability of the structure of the joining. The result of the analysis revealed that the structure of the jointer and pipe joining will not be subjected to the structural failure. It is because during the test carried out using SolidWorks simulation software, the maximum stress induced are less than the yield strength of the material. The lowest factor safety is 1.2, and that all maximum structure deflection are within the allowable deformation limits of the material used in the greenhouse construction. All the objective of this research is achieved. There are few recommendations for future studies are provided to improve these strength analysis studies. The result from this research can be improved by conducting more testing in SolidWorks software such as dynamic analysis, thermal analysis, motion and vibration analysis. Other than that, conducting the tension and fatigue test in the laboratory will provide more accurate result. The tensile strength of a material is typically measured in pound per square inch or other similar unit of the measurement. This parameter, as well as the material modulus of elasticity and yield strength, ultimate tensile strength and ductility, strain hardening characteristic, Young modulus and Poisson ratio, all can be determined using this technique. It is possible to perform fatigue testing on material by subjecting them to an accelerated simulation of repetitive loading in a laboratory using a fatigue tester. The number of repetitions is kept track of until this material fails. Also, other than that, multiple destructive tests and non-destructive tests can also help to improve the outcome of this investigation. The use of a combination of different NDT method is a more effective way to evaluate the strength of jointers and pipe connection, as well as to inspect the structure for any abnormalities that may exist. Finally, in order to ensure the effectiveness of the evaluation process, a better understanding of the background study, advantage, and scope of research of this strength analysis studies is absolutely necessary to ensure its effectiveness. That's all from me. Thank you for watching.